This is Lab 3, Black Hole and Orbits. The purpose of Part 1 is to use motion data to determine the mass of the black hole. And the purpose of Part 2 is to simulate interactions between the planet, moon, and ship to determine initial velocity needed to achieve a figure-8 orbit. This is Newton's law of universal gravitation. This is the formula and how it works. And then the principles used in this lab are the momentum principle, update formulas, and the idea of parallel and perpendicular forces, which is shown in this photo. The assumptions are that the mass was 2e to the 30. This was the initial velocity, and the only outside force was gravity. The hole and planet are stationary, the time step is constant, and Newton's second law and the law of universal gravitation are both valid throughout, and the system is isolated. So for part 1, this was my code. This was the mass of the star and what I made delta t, and then these were edited so that we could properly calculate what was needed. The system is the ship, and then the surroundings are the planet, moon, and gravity. This was the result, and for the mass I got 1.5015 e to the 34, which was found by averaging all of those values. And then for part 2, this was the code. These were my initial conditions, and then these were the formulas that I input to create the orbit. And then my result for this, it did orbit, and it exhibited the necessary interactions. However, I was unable to achieve a perfect figure-8 orbit. Errors in this lab were excessive rounding in the calculations. They weren't very accurate. There were lots of assumptions, like the forces that were acting, the laws that were valid, and the point masses. And there was a lot of trial and error, to find the velocity. The net force and rate of change of momentum represent the same physical relationship. Parallel components change speed, and perpendicular components change direction. And then a model must include all gravitational interactions between the bodies, but the black hole and star would likely dominate. And that's it.